Okay, this is a set of notes on symbolic logic for geometry. Okay, so previously we got the idea that if I have an if-then sentence, it's what's called a conditional statement. And so it has if some p, then q. Now we're going to represent this symbolically as p arrow q. You can read that as p implies q, or if p then q. So that's our symbol for this. We also had the idea of a converse. So if I take the converse of the statement, I take the hypothesis and the conclusion and I switch them. So that gives me if q, then p. So the symbolism for that is going to be q implies p. Now, there are two other ways that I can rearrange the conditional statement into things that have meaning. Now, I want to note that we said that the conditional and the converse have independent truth values, so the conditional can be true while the converse is false. So these things are somewhat independent of each other. The next one is what we call an inverse. So if I take the inverse of the conditional, I say it is if not p, then not q. So now we've negated both the p and the q. So in this statement, we would write this notationally as not p implies not q. So it's the same as the conditional statement, but we negate the two parts. So like if today is Monday, then tomorrow is Tuesday. The inverse would be if today is not Monday, then tomorrow is not Tuesday. Okay. Now, I also want to note that the inverse and the conditional statement are also independent as far as their truth values. The conditional can be true and the inverse can be either true or false. So these are independent. Okay, the last way that we can rearrange this into something is what we call the contrapositive. And the contrapositive is now if not q, then not p. So we've switched the q and the p and we've negated both. So if you're going to write this as a symbol, you would write if not q implies not p. Okay, now here's the interesting piece. The contrapositive and the conditional must have the same truth value. So if the contrapositive is true, then the conditional is true. And if the conditional is true, then the contrapositive is true. If one's false, the other one's false. So they have to have the same truth value. So if we think about this, like the conditional, I could say something like, if you are a garrison forest student, then you attend a private school. The contrapositive of that was, if you don't attend a private school, then you're not a garrison forest student. So you can see they have to have the same truth value. Now, at that claim, the converse and the inverse are both false. But notice, if you take the converse and you switch it and negate it, you get the inverse. So the converse and the inverse must have the same truth value as each other, because the inverse is the contrapositive of the converse. And that's a little bit confusing, and I get that. But these two have to have the same truth value, and these two have to have the same truth value. Okay, 4 types of statements and all of this. All right, so this is all symbolic kind of stuff. We're going to build what's called a truth table here to kind of see how some of this plays out. Okay, so we're going to build a truth table. What does that mean? All right, so in a truth table, we're going to set a P, and we're going to make a Q. Okay. All right, so the P has 2 trues and 2 falses. The Q has a true, a false, a true, and a false. So these are the 4 possible combinations of P and Q. True, 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 false, false, true, false, false. Okay, so we're going to list out the 4 statements that we had. We have the conditional statement, we have the converse, we have the inverse, and we have the contrapositive. So these are the conditional statement, the converse, the inverse, and the contrapositive. Okay, so and we're going to make this into a table. Okay. So if I have a conditional statement where I have a true hypothesis leading to a true conclusion, then I say that the conditional statement is true. If I am a Garrison Forest student, then I go to a private school. That's a true statement. The true hypothesis leads to the true conclusion. Okay, so the only way that a conditional statement can be false is if I have a true hypothesis leading to a false conclusion. Okay, if I am a Garrison Forest student, then pigs can fly. Okay. You being a Garrison Forest student doesn't mean that pigs are flying. That's a false statement. Okay. So this is the only way that I can get a false statement from a conditional. True to false. If the hypothesis is false, I actually say that the statement is true. Okay, that's a little bit not illogical, but counterintuitive. For example, if pigs can fly, then you are a Garrison Forest student. Okay, that's a true statement, okay? Because we don't know what's going to happen if pigs fly. So if I have a false hypothesis, I just account the whole thing as true because there's no obligation of the second part to have any truth value whatsoever. So it could be true or false. It's still going to be a true statement. Likewise, if pigs could fly, I'm a millionaire. Okay, that's a true statement too, because pigs can't fly. So it has no bearing on whether or not I'm going to be a millionaire. So the only way you can get a false is a true-false combination. Now, let's look at what happens here. If I switch the P and the Q for the converse, so the Q is going to come first and then the P. Okay, so this true is still true Q implies true P, still true. Okay, now I have false Q implies true P, but the hypothesis is now false, which makes the whole statement true. Okay. True leading to false. True Q leading to false. True to false is the only way I can get a false. False, false, the hypothesis is false, which means the whole thing is true. Okay, so this is why we say that the conditional and the converse are independent. These two sets of truth values are not the same. So it is possible for this to be false and that to be true. It's possible for this to be true and that to be false. So they are not necessarily going to have the same truth values. Now let's look at what happens with the inverse. Okay, so we're going to negate both P and Q. So P is normally true, but if I negate it, it's going to be false. Q is normally true. If I negate it, it's false. So this would be false, false. False hypothesis makes the whole thing true. Okay. So let's negate the P again. True now becomes false. Negate the Q, that becomes true. False, true. The hypothesis is false. The whole thing is true. Okay, so let's look at this. Not P, false. False becomes true. Not Q becomes false. This is true, false. That's the only way I can get false. True, false. And now I have not P, so not false is true. Not Q, not false is true. So that's true, true gives me true. And if I look, the converse and the inverse have identical truth values. That's why I know that when the converse is true, the inverse must be true, and when the converse is false, the inverse must also be false. All right, so let's play the game with the contrapositive. Not Q. So that's the opposite of true is false. If the hypothesis is false, the whole thing is true. Okay, so how about this one? Not Q. The opposite of false is true. Implies not P. The opposite of true is false. True implies false. That's the only way I can get false. True implies false. Okay, so not Q is false. If the hypothesis is false, the whole thing is true. And then the last one here, not Q, not false is true. Implies not P, which is also true. True implies true means true. Okay, so now let's look at this. The conditional here, true, false, true, true. The contrapositive here, true, false, true, true. These are identical. So when the conditional and the contrapositive say the same thing, this means they have to have the same truth value. When the conditional is true, the contrapositive is true. When the conditional is false, the contrapositive is false. True, 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 true. They have the same truth values all the time. Okay, so this is a lot to digest. It's a little bit long of a set of notes and video. It's a little bit abstract, but we will work on this in class a bit. All right, so let's do a quick summary of this. You have 4 types of statements. You have the original conditional, the converse, the inverse, and the contrapositive. The conditional is if P, then Q. The converse switches the Q with the P. The inverse just negates both the P and the Q. And the contrapositive does both switching and negating. The conditional and the contrapositive must have the same truth values. Likewise, the converse and the inverse must have the same truth values. So there's your summary of our lesson, and we'll go from there.